Hello, boys and girls. In lesson 3.4, we will be looking at scale factor. We will be able to identify the scale factor given two figures by creating a ratio with a corresponding side length. So let's begin by creating a definition for corresponding sides. Can you identify the corresponding sides in the image below? Pause the video to think about it. Let's define corresponding sides. Corresponding sides are a pair of matching sides that are in the same spot in two different shapes. So let's take a look at triangle X and triangle Y. The corresponding sides in these triangles have been color-coded. So line AB corresponds to line RS. Notice that when I am reading the lines, point A was said first, just as point R was said first, because point A and point R correspond to each other in those two triangles. Notice that B was said second, just as S was said second, again because B and S correspond to each other. Let's continue looking at the corresponding sides. Line BC corresponds to line ST. Line AC corresponds to line RT. The scale factor is the number that the side lengths of one figure can be multiplied by to give the corresponding side length of the other figure. So let's take a look at this particular example. We have to find the scale factor from the smaller rectangle to the larger rectangle. Independently write out your thought process for solving this problem. What would be your starting point to solve this? Pause the video to think about it. Let's take a look at the steps to solve this problem. So to find the scale factor from the smaller rectangle to the larger rectangle, before to after, the first step is to label the figures A and B to help identify them. Next, choose one side from each figure and make them corresponding sides. So in figure A, I am going to choose the side that is labeled 10. The corresponding side in figure B would be 20. Next, divide the chosen side from B, which is the after, by the chosen side from figure A, which was the before figure. So we write 20 divided by 10 to receive 2. So the scale factor from smaller to larger is 2. So now, do you think that the scale factor would be the same if we went from larger rectangle to smaller rectangle? Let's take a look at an example. So in this particular example, we are finding the scale factor first from the small figure to the large figure, and then we will find the scale figure from the larger figure to the smaller figure. So let's go through the steps. Step 1 is to label our figures. Let's label the smaller one A and the larger one B. So according to the steps, the next one is to create or to select our two corresponding sides. I would like to choose the smaller side of the rectangle, which was 3. So the smaller side of rectangle A is 3, and the smaller side of rectangle B is 9. So if you notice, the rectangle was flipped onto its smaller side. Don't let that fool you. The smaller side corresponds to the smaller side. So let us write our division problem. We want to go from smaller to larger. Therefore, we will divide the side length of the after image by the corresponding side length of the before image. Therefore, we are dividing 9 by 3, and in doing so, we get a scale factor of 3. Now let's take a look at the other way around. Let's see what happens when we go from image B to image A. So we will take our after image, which in this case is A, and our starting image, which is B, because we started with image B now, and we're going to image A. This time I want to select the longer side. So the longer side value is 18 in B and 6 in A. So let us write them down, make sure that we match them up. So for A, the side length is 6, and when the side length is 6 for A, the corresponding side length is 18 for B. Now I know I can't divide 6 by 18, so I can just reduce this to 1/3. Therefore, the scale factor when B became A was 1/3. And this makes sense. Why? Because B became smaller to become A. A fraction, A is a fraction of B. Let's take a look at another example. In these examples, we are given the scale factor and we are being asked to create a scale drawing from the actual picture. So if we are given this envelope and we know that the envelope is 1 inch in width, then in order to find out what a scale drawing that is larger than that envelope with the scale factor of 4, it will be larger, we need to multiply that dimension, 1 inch, by 4 to give you a scale drawing of 4 inches. With the scale factor of 4, our image would become bigger. Let's take a look at the price tag. The scale factor used in part B is 1/2. So what do you think will happen to the size of the price tag? If you said it will become smaller, you are correct. So if we start with a dimension size of 2 inches and we apply a scale factor of 1/2, that means we will multiply it by 1/2. So let's put those 2 inches over 1. We can cross cancel to multiply 1 times 1. 1 over 1 is equal to 1. Therefore, it will shrink down to 1 inch.